what our plan for today is to give an introduction to this summative lab report that I'm going to ask you to write based on some data that you are going to have to calculate and measure and analyze. So you need to find percent yield of a lab. The quiz you just took, you had to find percent yield. Hopefully you remembered that actual yield is what you actually make in the lab. Theoretical yield is what the math says you should make. And then percent yield, you divide those two. Actual divided by theoretical times 100 gives you percent yield. So what I'm going to ask you guys to do in this lab is actually make some stuff and then calculate your percent yield. Today we're going to introduce the assignment. We're going to do some practice math. You are each going to do your own math, and hopefully we also get to mix our chemicals today. People at home, you're like, how am I going to mix my chemicals? I promise we have a plan. So here is our assignment. Everybody is going to be given not 10 grams of copper to make, but we are going to all have to make some amount of copper. So you are going to have to determine the masses of aluminum and copper 2 chloride dihydrate that we need to mix together in order to produce, for our example together, we're going to do 10 grams of copper. You are going to have a different amount. In fact, each of us is going to have a unique amount so that everybody has to do their own math. It's a single replacement reaction between aluminum and copper 2 chloride dihydrate. We're going to produce copper. Where should we start? What should we do first? Step 1, what should we do? Do what? Find molar masses? We could. I feel like there's something that we could do before. And friends at home, if you're putting things into chat, chat is not working for me right now. I can't see chat. So even before we find molar masses of what? Aluminum and copper 2 chloride, copper. Is there anything else being produced in this reaction? What should we write to figure that out? Friends at home, chat's probably full of the answer. What do I need to write? Balanced equation. We need to write an equation and balance it. So we are going to combine aluminum is Al, copper 2 chloride dihydrate. I need to figure out how to write that formula. Copper is Cu. What does that Roman numeral 2 tell us? It has a charge of +2. Perfect. Chloride is Cl. What's the charge of chlorine all the time in an ionic compound? -1. So I have a +2 and a -1. Those don't balance out. So how am I going to write this formula? CuCl2. Perfect. Tell me about this dihydrate thing. What does this even mean? Two hydrates. What's hydrate? If you're dehydrated, what are you missing? Water. Dihydrate is 2 waters. So this is 2 H2Os. So we're going to combine aluminum and copper 2 chloride. Whoa, I lost my L. Copper 2 chloride dihydrate. Remember how we did the dot and the number and the water? Copper 2 chloride dihydrate. We're going to produce copper, obviously. And what else? It's a single replacement reaction. So if copper pops off the chloride, what's going to pop onto the chloride? What? I think somebody said it. When copper pops off the chloride, what's going to take its place? It'll be replaced by aluminum. Exactly. So copper is going to get knocked off the chloride. Aluminum is going to jump on. Aluminum chloride. Aluminum has a charge of +3. Chlorine is still a -1. So what do I have to do to get these guys to balance out? Perfect. Aluminum chloride is not a hydrate. It's just aluminum chloride. So that means I also have to do something with my waters. So we're also going to have some water that instead of being stuck to something is now just floating around in our beaker. We have an equation. We do not have a balanced equation. So what are we going to do next? How can I balance this guy? I have 3 chlorides. I have 2 chlorides. What's my least common multiple for 2 and 3? 6. Perfect. So I have a 2 here. What coefficients should I put here? 3 to get to that 6. Exactly. And here is going to have to be a 2. So 2 times 3 is 6. 2 times 3 is 6. But now I have 3 coppers, so I need 3 coppers. And I have 2 aluminums, so I need 2 aluminums. How many waters are going to pop off and float around our beaker? So close. Woo, 6, exactly. 6 waters, because I actually have 3 copper 2 chlorides that are stuck each to 2 waters. So 2 and 2 more, 2 more makes 6. Yay, we have a balanced equation. So now that we have our balanced equation, we need to start doing some math to figure out all the other things that need to happen. So I need to determine the masses of aluminum. How many grams of aluminum should I add to how many grams of copper 2 chloride dihydrate in order to make 10 grams of copper? I need to figure out how many grams of aluminum should I mix with how many grams of copper 2 chloride dihydrate in order to produce 10 grams of copper. How should I do that? What should I start with? We've got our balanced equation. What's next? Turn our grams into moles. Perfect. So we're going to always start with our given. 10 grams of copper is our given. Turn those grams into moles. I have my periodic table right under my drawing tablet. Haha. What's the molar mass of copper? .546 grams per mole. So I have successfully canceled out my grams of copper. I have moles of copper. As soon as I have moles of copper, I can do what? Flip my given into my wanted. What are our wanteds? There's 2 of them. What are our wanteds? Exactly. All those words. Exactly. Aluminum is one of our wanteds. Copper 2 chloride dihydrate is the other wanted, which means that we're going to have to do railroad tracks 2 times. 1 time to get aluminum and 1 time to get copper 2 chloride dihydrate. Let's do aluminum first. So I have copper on the top. I want copper to go away. I'm going to put it on the bottom. Perfect. I want to flip that copper first into aluminum. I'm going to put aluminum on the top. What coefficients should I use? What needs to go in front of aluminum? 2. What needs to go in front of copper? 3. Perfect. So now we have successfully canceled out the copper. We have moles of aluminum. Do our scales in the lab measure moles? Nope. I need to turn our moles into grams. Exactly. Perfect. So we need one more little chunk of railroad track. I have mole on the top. I want mole to go away. I'm going to put it on the bottom. But this time I'm looking at aluminum. So I need the molar mass of aluminum. Or if you're in England, aluminium looks like 26.982. 26.982 grams per mole. So now we have canceled out our moles. We are left with grams of aluminum. Handy dandy calculator. 10 times 1 divided by 63.546 times 2 divided by 3 times 26.982 divided by 1, and it looks like we need 2.83 grams of aluminum. I'm going to go to the lab and I'm going to take a piece of aluminum foil and I'm going to get 2.83 grams of aluminum. And I'm going to mix it with some copper 2 chloride dihydrate. How much copper 2 chloride dihydrate? Well, you need to do another railroad track. We're going to start with that same given. I still want those 10 grams of copper, right? So we're going to start with 10 grams of copper. We always have to get rid of grams first, turn our grams into moles. This first part is going to look exactly the same. 1 mole of copper has a mass of 63.546 grams. Periodic table says so. So we have canceled out grams of copper. I have moles of copper. Now I can flip my chemical into the other chemical. I have copper on the top, I'm going to put copper on the bottom. This time I'm going to flip copper into what? Not aluminum. We're not going to flip it into aluminum this time. I already know how much aluminum. What else do I need to know? Copper 2 chloride dihydrate. So this other one is going to be copper 2 chloride dihydrate. What coefficient should I put in front of copper 2 chloride dihydrate? 3. Perfect. And what goes in front of copper? Also 3. Easy peasy. So now we have successfully gotten rid of copper. I have moles of copper 2 chloride dihydrate. I do not have a scale that measures moles. I only have a scale that measures grams. So now we need to convert our moles into grams. We're going to do that by putting moles on the bottom, put grams on the top. What's the molar mass of copper 2 chloride dihydrate? Oh my gosh, that's a lot of stuff. It's copper 2 chloride dihydrate, which means that I need 1 copper. Copper is 63.546. I have 2 chlorines, so I'm going to add 2 times 35.453 because chlorine is 35.543. How many total hydrogens do we have? How many total hydrogens? 4. So we're going to add 4 hydrogens. And how many oxygens do we have? 2 oxygens. Perfect. Add up all those guys. 63.546 plus 2 times 35.453 plus 4 times 1.008 plus 2 times 15.999 looks like a grand total of 170.482 grams per mole. So that's going to allow us to cancel out moles. We're left with grams of copper 2 chloride dihydrate. Do that math on your calculator. 10 times 1 divided by 63.546 times 3 divided by 3. You can totally skip that step. They cancel each other out. Times 170.482 is going to give us a grand total of 26.8. And lots of decimal places, but sig figs, I keep 3. I have my 2 quantities. I need to get a beaker and mix in my beaker 2.83 grams of aluminum and 26.8 grams of copper 2 chloride dihydrate. They should react, and I should get 10 grams of copper. What that looks like when we actually go to the lab and do this, we're going to have in the lab some jars of copper 2 chloride dihydrate. You're going to get this thing, it's called a weigh boat. You're going to use the weigh boat and this device that's called a scoopula, and you are going to measure your amount of copper 2 chloride dihydrate. For our example, I should measure 26.8 grams. Your quantity will not be that same amount. But I'm going to use my scoopula to scoop out the copper 2 chloride and put it in the weigh boat until I have that right amount. I'm going to take all of my copper 2 chloride from my weigh boat and I'm going to dump it into a beaker. I'm going to add water. This is water. I'm going to add just enough water to dissolve my copper 2 chloride dihydrate. So here you can see it's like a crystal. I added water, and that's what that blue solution is in this beaker. So we're going to measure our mass of copper 2 chloride dihydrate. We're going to add enough water. It doesn't really matter exactly how much it is, as long as it is completely dissolved. You want all that copper 2 chloride to be dissolved. And then we're going to also use a weigh boat to measure the grams of aluminum that we need. We're literally going to use aluminum foil. There's a roll of Reynolds wrap in the lab. Your reaction happens way better if you have little pieces than if you have like a big ball. So don't crunch your aluminum foil into a ball. You do want like tiny little pieces. Your reaction will happen better. And you can see here in this last picture, there's already a little bit of a color change happening. The aluminum is leaving those chunks of foil and is reacting with the chloride ions in the solution. This dark stuff that we're starting to see, that's the copper that is no longer stuck to the chlorine, but instead is becoming a copper metal, which will not dissolve in water. So far, so good. Questions about anything that you see on the screen? And friends at home, I can't see chat. So if you have a question, unmute for a moment. So far, so good. All right. So after a little while, your aluminum, copper, mixy stuff is going to look like this. There's going to be some bubbles. It's going to definitely change color. And eventually, all of the aluminum pieces are going to disappear because the aluminum is totally floating around in the beaker. And what will happen is all the copper that was produced is going to settle to the bottom of the beaker. All these little chunks are chunks of copper metal that used to be in copper 2 chloride, but now aluminum took over the chloride and copper is left by itself. All of these little pieces kind of looks like the surface of Mars. Yeah, this is our copper here on the bottom. Copper. So we need to figure out how much copper has settled to the bottom of the beaker. What we're going to do is filter out that copper metal. So you're going to get a piece of filter paper. I like to use pencil to write on the filter paper so that I know which is which trial, because maybe we want to do more than one trial. So I'm going to put my initials. This is my fake student name. I like to call myself I'm a student. And so my initials, I'm a student, are here. Trial number 1. I'm going to measure the mass of my filter paper using the scale. And then I'm actually going to write also that on my filter paper so that I know what its mass is. That's going to be important shortly. So then I'm going to take my beaker and I'm going to pour it into, there's a funnel here. It's easier to see in this picture. So you've got a funnel sitting in a flask. There's a flask. There's a funnel. I'm going to pour all the stuff that was in my beaker, all the stuff that's in my beaker, I'm going to pour it into the filter paper that's inside the funnel. My aluminum chloride is going to go right through the filter paper, and it's going to end up down here in the bottom of my flask. My copper is going to get stuck. You can kind of see that dark reddish stuff is already stuck in the filter paper. I know I colored all over this one. You can see in this picture, you can see here, there's some copper that's stuck in the filter paper there. So aluminum chloride is going to go right through. The copper is going to get stuck in the filter paper. And then you're going to leave it alone for like a day or two, or perhaps even the whole weekend. And then you're going to have this dry, crusty piece of filter paper with copper stuck in it. You're going to take this guy, put it on the scale, measure the mass of the filter paper plus copper. And then we do the math. So if my filter paper was 0.85 grams, and at the very end of my investigation, I measured the mass of the filter paper and the copper to be 9.87 grams, how much copper did I actually make? How could I figure out how much copper I made? Add, subtract, multiply, divide. Subtract. 9.87 minus 0.85. If I take the filter paper away from filter paper and copper, I have just copper by itself. So the copper by itself is 9.02 grams. I want to calculate percent yield. This 9.02 grams, is this my actual or my theoretical? It's my actual. What's my theoretical? How much should I have made? How much copper should I have made according to my math? Let's go look at our math. How much copper should we have made? 10 grams. That's our given. That's our theoretical yield. Theoretically, we should have made 10 grams of copper. We only made 9. So then we do our percent yield formula, actual over theoretical times 100. Looks like we made 90.2% of what we should have made. Voila, the lab is done. We type it into a lab report and get a lovely grade in Hack. Good? Questions about any of that? All right, so your assignment is this. Connected learners, you got an email from me. Face-to-face learners, you're about to get a piece of paper from me that has a specific amount. Each and every one of us has a different amount of copper. None of us can copy each other's math because we all have unique math. But also, that right there, that's the setup for all the math. It's just this starting quantity is going to be different for each of us, but the setup is going to stay the same. So you're actually going to do the calculations, figure out how much aluminum you need to mix with how much copper 2 chloride dihydrate. We're going to actually mix those things, and we're going to filter out the copper, and we're going to see what our percent yield is. People who are here, your job is going to be, as soon as I give you your piece of paper, do your math, figure out how much aluminum, how much copper 2 chloride dihydrate. The goal is to get those quantities calculated today, so that you can go to the lab and actually start mixing those things today. Friends at home, here's where the excitement and the We're going to try this and see how it goes. If you are so excited about this and you want to mix things yourselves, and you feel safe coming to school on a Saturday when the crowds are very small, I will be here at school this Saturday and also next Saturday mornings. So you can come at any point between 9 and 1. You don't have to come at 9 and stay till 1. You can come from like 10 to 10:30 or 12 to 12:45, or you can stay the whole day, totally up to you. You can come to the lab on a Saturday. You can mix your chemicals this Saturday. You can calculate final masses, your filter paper masses, next week Saturday, if you feel safe, if you can. If not, I'm about to send you a Google form in which you're going to tell me how much to mix. Let me show you what that Google form looks like. If I can find, there it is. All right, so this is the Google form that you're going to get in Canvas announcement, not email, Canvas announcement shortly. So what you're going to do is you're going to type in your name, and you're going to tell me that you're supposed to make 10 grams of copper, and then you're going to type in whatever mass of aluminum, whatever mass of copper 2 chloride, dihydrate, how many trials, I don't know, that's up to you. And then here you can tell me what you want me to do. Maybe you want to come this Saturday and you are going to measure and mix things and you're going to filter, but you can't come next Saturday. So Ms. Lentz needs to measure the filter paper of the product at the very end of the investigation. Or it might be that you cannot come to the lab on any Saturday, and so Ms. Lentz needs to mix and measure everything for you. Or it might be that you're going to do everything yourself. You will be here both Saturdays. You can get it all done by yourself. And then you just submit. And then I will have a spreadsheet of who I need to mix for what. You received from me, Connected Learners, last night. You should have gotten an email with your quantity of copper. You also should have received an invitation to a shared folder. In that folder, I am going to put pictures of your stuff. I'm going to put your quantities so that you have everything that you need. Unless you're here, in which case I'm not going to put anything in your folder. Does that make sense? Do we think it's going to work? Yes, good. I think so too. Connected Learners, thumbs up for me that you got an email with your quantity and a link to that shared folder. Awesome, perfect. Hopefully that email makes a lot more sense now than if you looked at it last night. And someone asked in chat, so for your amounts, are you just going to do the same calculation, just start with your amount instead of 10 grams? Yes, absolutely. Absolutely, yes. Good. Good? All right. I'm going to go ahead and send that announcement with the link to the Google form. That's all I've got for us today. If you have questions, I will linger and answer. No questions, go forth, my friends, do your math. Watch for that announcement with the Google form. Tell me what you want me to do and what you, the lab is kind of fun. You might want to come play in the lab a little bit. Good?